Okay, the last segment is on integrating and differentiating. We're going to do it in that order. Here comes the example for integration. Let's say f prime of x is told to us, we know that f prime of x equals x e to the x. And they tell us that f of 0 equals 2. Can we find the Taylor series of f of x at 0? X e to the x. Find the Taylor series. All right, all right. Let's see. Well, x e to the x. I know the Taylor series for e to the x. So let's start with that. Rewrite f prime of x as x times, and then the Taylor series for the e to the x. Just replace that guy right there. 1 plus x plus 1 over 2 factorial x squared plus dot 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 plus 1 over n factorial x to the n plus dot dot dot. Okay, well at this point now we're multiplying by x, so go ahead and distribute. So we'll simplify f prime like so. X plus x squared plus 1 over 2 factorial x to the third plus dot 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 1 over n factorial x to the n plus 1 plus dot dot dot. Okay, now that we know the Taylor series for f prime, now we can use that to get the Taylor series for f of x. What do we need to do to get f of x if we know f prime? Well, take the antiderivative, right? Integrate. So we're going to integrate both sides. And here I'm just getting it ready. Let's go about right there. So I'm writing, okay, integrate f prime, that's f prime. The integral of the previous line, all of that stuff that we just found. Oh, wouldn't you know it, I forgot to write dx on the end. We need that dx. Integral of all this with respect to x. Don't be intimidated. What's going to happen? Well, obviously the antiderivative here is f of x. That's why we're doing this in the first place. How about that right side? Well, true, it's infinitely many terms, but we're not going to show all infinitely many. We're just going to do the first 3 and then the nth term. Notice the plus c we put at the beginning, not at the end. Why is that? Because a Taylor series, it always shows increasing powers of x. So here we start with x squared. Well, sorry, okay, back here, we're beginning with x, which leads us to x squared. That's we multiplied by x on a previous step, so we're missing the x term for that reason. But okay. So we're doing these antiderivatives, but then the c we want at the beginning because we want that. That's the smallest. That's like x to the 0, right? And then we go for increasing powers. All right. So the c is at the front plus. And then we just take antiderivatives, right? 1/2 x squared, 1/3 x to the third. When you get to this one, 1 over 2 factorial, one of two ways you could do this. Now, 2 factorial is 2. So you could say, oh, that's x to the fourth, so 1/8 x to the fourth. Nothing wrong with that. I left the 2 factorial and I just said 4 times 2 factorial because, that the factorial is just kind of part of the nature of the Taylor series for e. But if you wrote 1/8 here, I think that would be fine. When you get to the nth term, though, you don't have that luxury because you just have n you're working with. So let me make this a bit darker. It's coming out kind of light on the video. 1 over n factorial x raised to the n plus 1. Okay. So the next highest power is n plus 2 if I add 1. So that means I would need to divide by n plus 2. So 1 over quantity n plus 2 n factorial. If I took the derivative, then I'd get back to here. Plus dot dot dot. And we've integrated. All right. We're not quite done though, because we're going to find the value of c. So they told us that f of 0 equals 2. We're going to use that to find the c. Very much like in the differential equations, right? Use f of 0 to find c. F of 0 equals 2. All right, so I'm going to plug in 2 here, and I'm going to plug in zeros for all of my x's. Right, I had 1/2 x squared plus 1/3 x to the third, right, x to the fourth, x to the n plus 2. Put a 0 in for all those. You're plugging in infinitely many zeros. But wouldn't you know it, plugging in 0 just wipes out all those terms. Probably why they gave us that value. So all these are gone, and we simply have 2 equals c. And then we go back and plug that in into that first position for our final answer. So here the Taylor series, f of x equals 2 plus 1/2 x squared plus 1/3 x to the third plus 1 over 4 times 2 factorial x squared plus dot 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 plus 1 over n plus 2 quantity n factorial x raised to the n plus 2 dot dot dot. Only difference, from that line on the previous page is I have the 2 there, the c value. So that is integrating a Taylor series. Our last operation, we got one example of these. We are given g, and we're asked to find the Taylor series for g prime. So the reverse of what we just did, obviously we'll need to take a derivative. So g of x, and they're just telling, all right, this is part of the problem. So g of x, they're telling us equals x minus 1/3 x to the third plus 1/5 x to the fifth minus dot 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 plus negative 1 to the n over 2n plus 1 x raised to the 2n plus 1. So you notice we have the odd numbers, right? 1, 3, 5. 2n plus 1 will get you the odd numbers. So if you started at 0, right, n equals 0 is 1, n equals 1 gives you 3. So kind of an interesting, kind of a, that's the pattern for getting the odds, 1, 3, 5. All right, anyway, that's really not even important. Just something to notice. So they're giving us g, we want g prime. Well, we're going to just go down the list and take derivatives. Nothing more to it than that. So here's our answer. 1, and that derivative, well, it's just minus x squared. This one happens to be plus x to the fourth. When you get to the nth term, well, multiply, by 2n plus 1, and it would cancel. So all you have is negative 1 to the n, and reduce your power by 1, x to the 2n plus dot dot dot. When it comes to the derivatives and the integrals, we're not going to ask for the interval of convergence because it's not as simple as the other questions. There'd be a lot more work to it, so we're not going to encumber ourselves with those things. That is the end of 10.3. Check out the homework. See you in the live meeting.